Hello everyone, our next experiment is specific heat. The aim of this experiment is to determine the heat capacity of calorimeter, melting heat of ice, and specific heat of copper. The basic principle of the heat capacity is related to the Black principle as we learned it a long time ago. We know that the specific heat is the amount of heat required to reach the temperature of 1 gram of substance by 1 degree. So we can say that the heat capacity of calorimeter is the amount of the heat that required to raise its calorimeter temperature by 1 degree Celsius. And the melting heat of ice is also could be defined as the amount of the heat that required to change 1 gram of ice from the solid phase to liquid phase. And the specific heat of copper is the amount of the heat that required to raise the temperature of 1 gram of copper by 1 degree Celsius. Let's remember again that the heat is defined as the transfer of energy from or into a system because of a temperature difference between the system and its surrounding. The transfer of the heat are carried out in a devices called calorimeters. Calorimeters are insulated to prevent loss or gain of heat between the calorimeter and its surrounding, so that the heat flow in the system can be measured. In the right side of this slide, you can see that the quantity of the heat is given the symbol by Q, and the formula is Q equal to M times C times delta T, which C stands for the specific heat, M stands for mass in grams, and then the delta T is the temperature change in Celsius degree or Kelvin. Now, if we remember again the Black principle in the calorimeter system, we have a picture here, the illustration of the calorimeter. The calorimeter consists of a calorimeter protector and also a thermometer, a stirrer, a water, a calorimeter tube, and a flap. And we have to remember again about the Black principle, how the heat released by the system that have a high temperature to the surrounding. The surrounding is also a system that will receive the heat transfer of that. And in this formula, we can see here that the Q release by the hot water and will be received by the calorimeter itself and also the water. So we have to describe and analyze the formula corresponding to the Q receive and also the Q release. And you can see that the formula is about the mass of the calorimeter times the specific heat of calorimeter times the difference between the temperature difference between the final temperature and also the initial temperature, and also sum with the mass of water times specific heat of water times the different temperature between the final temperature minus initial temperature, or subtract by the initial temperature, and thus is the Q received by the surrounding of the hot water, and it will be equal with the mass of hot water times specific heat of hot water times the temperature difference between the hot water temperature subtract with the final temperature, or TF. Material and tools. We have a calorimeter with a complete set, including inner calorimeter vessel, external calorimeter vessel, stirrer, thermometer, and also calorimeter flap. and we have a boiling vessel, and then a copper metal heating tube, and also a torch balance and subsidiary balance, and we have electric stove, and also baker glass, a small pieces of copper wire, and Lamaya water heater with plastic hose, and also water. Now we move to the procedure. The first thing we will do is determining the heat capacity of calorimeter. Pour the water into the boiling vessel from the baker glass, and then put it in on top of the electric stove, and then switch on to heat the water inside the boiling vessel. And then take the inner vessel of the calorimeter and make sure that it is in an empty state, and then put it on a balance source, and you have to weigh the mass of it. And don't forget to set the scale accordingly so that it can reach the equilibrium state, and then you have to record this result measurement of the inner vessel calorimeter mass in an empty state. After that, open the clap of the inner vessel of calorimeter and pour a water from the baker glass, and then close again the clap, and you can reweight again the mass of it. Don't forget to set the balance scale accordingly, and record the result measurement for this mass measurement. And then put the inner vessel of the calorimeter in the calorimeter, and put the thermometer inside it, and you can read the temperature of the water inside the calorimeter, and don't forget to make a note for it. After that, you can switch off the electric stove and open the clap of the calorimeter, and then pour the hot water from the boiling vessel into the calorimeter. And be careful by doing that, because the boiling vessel is so hot. And stir friendly the calorimeter so that the hot water will mix with the cold water, and then you can observe the rising of the temperature shown by the thermometer. And don't forget to make a note from this temperature measurement. After that, take out the thermometer from the calorimeter and pull off the inner vessel of calorimeter and put it on the balance torque, and don't forget to weight again the mass, and set the scale balance accordingly, and record the mass measurement from that part. So this mass is a mass of the inner vessel calorimeter plus water, and also plus hot water.
Our second experiment is about to determine the heat of a melting ice. Generally, the step is the same as the previous one, that we took the inner vessel of the calorimeter in an empty state, and we have to weight the mass of it. And don't forget to set the, the balance scale accordingly in a balance source, so that it can reach a equilibrium state. And don't forget to record the mass of it. After that, you can open the flap of the inner vessel of calorimeter and pour some water from the beaker glass into it, and close again and reweight again by using the balance store. And don't forget to record this mass. The mass of the inner vessel calorimeter containing a water. Be careful by setting the scale of it. After that, put the inner vessel of calorimeter inside the calorimeter and place the thermometer inside it. And then you have to observe the temperature of the water inside the calorimeter. And don't forget to record and take a note of this result measurement for the temperature for the water. Open the flap of the calorimeter and pour some ice cubes inside the calorimeter, and then stir gently the stirrer of the calorimeters, and you can observe the decreasing temperature shown by thermometer. And be careful while you observing the temperature decreasing, and while also you are stirring it. And then record this temperature result and take out the thermometer from the calorimeter, and take out the inner vessel of calorimeter and reweight again by using the balance store, and set the scale balance accordingly, and then record or take a note from this mass measurement result. So the mass of this result is inner vessel calorimeter with the water and the ice cube. The third experiment is specially for determining the heat capacity of copper, like the two previous one. The first thing we will do is we have to weight the mass of the inner vessel of the calorimeter. Make sure that the inner vessel calorimeter in an empty state, and you can set the scale accordingly again and record the result. And be careful while you are doing it, because it's a little bit difficult sometimes to set the balance torque to reach a equilibrium condition. And then after that, take the inner vessel calorimeter, open the flap and pour the water from the beaker glass into it, and then close the clamp of the calorimeter, and then you have to reweight again the mass of it. So the mass of it consists of the inner vessel calorimeter and the water. Set again the balance scale accordingly, so and then you have to record the mass of it. And then after that you can take again the inner vessel calorimeter, put it inside the calorimeter, and then take the thermometer and put it in the water inside the calorimeter, and then you have to record the temperature of it. It should be around the room temperature because we use the usual water, not very cold and not very hot. And be careful while you observe the reading of the thermometer. After a while, leave and insert the copper metal heating tube into the boiling vessel, and then turn on the electric stove and heat the boiling vessel for some time. It will a little bit longer than water because it's a copper. Okay, after a while, turn off the electric stove and open the cap of the calorimeter. Be careful while you are doing it, and then pour the hot melted copper into it, into the calorimeter, and then close again the clamp and stir slowly and observe the temperature rise on the thermometer. You will see that the melting copper will give the heat to the water and the environment inside the calorimeter, and record the temperature measurement from this step. After that, you can remove the thermometer from the calorimeter and weight again the mass of the inner vessel calorimeter contains water and also the melted copper. And be careful by setting the balance scale accordingly, and don't forget to record the result of this mass measurement. This is the data table that you will get from the offline experiment or from our laboratorium staff. Especially for the experiment, you will get the information about the mass in grams and also the temperature in Celsius. And you already observe some variation of mass like M1, M2, M3, M4, M5, M6, M7. It's accordingly with the measurement result that we already obtained in the previous step. So you have to check your experiment module to know the meaning, the definition from M1 till M7, because we already observe and get the data for the mass of the inner vessel calorimeter, and also we do the mass measurement for the inner vessel in the water, and also the mass of the water, and also the hot water, and also the mass of the inner vessel with the water, and also with the ice cube. So like that you have to know, and you have to check accordingly. And then for the temperature also, you already get the data from the our previous steps, so do it accordingly. And then you have to process it to obtain the three main tasks, like the three main experimental we already did in the previous video. Okay. Here is your final task. You have to determine the heat capacity of calorimeter, and then the second one is you have to determine the melting heat of ice, and then the third is you have to determine the specific heat of copper. Okay, good luck for your report, and stay safe and stay healthy. See you in our next experiment. See you. Assalamualaikum warahmatullahi wabarakatuh.